Vectors in the rectangular plane. Given a vector v with this as the initial point and this as the terminal point, the vector v is written as the difference in the x's I plus the difference in the y's j. The position vector from the origin to AB, where this is your A, so that's A, and this is your B, so that's B, is written in this form. That's what I just said, right? This vector sum is called a linear combination of the vectors I and j. So this is a linear combination right here of the vectors I and j. And to get the magnitude of v of your vector, it's still the same thing that we've been doing. It's still the square root of a squared plus b squared. Let's look at an example. Given a vector v with the initial point p 2, -6 and terminal point q, -6, 6, write the vector in terms of I and j. Well, remember your formula. This is our formula for v. So it's going to be x2 minus x1, so -6 minus 2, I plus y2 minus y1, so 6 minus -6, j. So we end up with -8I plus 12j. We have written the vector in terms of I and j. Given an initial point P, 1, -1, 3, and terminal point P2 is 2, 7, write the vector in terms of I and j. Again, we use the formula that we had on the last page. And it says vector v, so v is equal to the difference in the x's, so 2 minus -1I, plus the difference in the y's, so 7 minus 3j. This is equal to 3I plus 4j. Find the sum of v1 and v2. Well, to find the sum, we use this formula. Remember, we have an A and a B. This is our A, this is our B. Now we also have a C and a D, where this is our C and this is our D. If you want, you can write all those in there. This is your A, this is your B, this is your C, this is your D. So we just use the formula, A plus CI, so in other words, add the A's, put an I, add the B's, put a J. So we have the sum is going to be V1 plus V2 is 2 plus 4I plus -3 plus 5J. 6I plus 2J.